In chapter 11.5, we'll be discussing about the areas and lengths in polar coordinates. So first we'll look at the area. We are given the formula for the area as the integration of half of the function square where the limit is from alpha to beta. So the formula is pretty simple, but we'll need to know how to sketch the graph and also to find the limits. For example, if we are given the curve r equals to f theta and we are required to find this area which is enclosed by the function and these two lines, our limit will be from this line where the angle theta will be equals to alpha to this line where the angle theta equals to beta. So now we'll do an example, which is to find the area enclosed by one loop of the lemniscate r squared equals to 4 sine 2 theta. First we have to find the limits, and to find the limits we have to let r equals to 0. Because when you have a loop, your r will be the distance from here to here, and at this point and this point your r will be equals to 0. So by letting r equals to 0, we can find the angle theta, which is the limit for the loop. When r equals to 0, the function for sine 2 theta will be equals to 0. So sine 2 theta equals to 0. For sine 2 theta to be equals to 0, the values of 2 theta are 0, pi, 2 pi, and so on. So divide these values by 2 and we'll get the values for theta. Since you're only finding the area enclosed by one loop, we'll only take these two for its limit. So we sketch the graph, and the limit is from theta equals to 0 to theta equals to half pi. This is our loop, and this is the area that we're looking for. We substitute these values into the formula, and we'll get the equation for our area. We simplify the equation, and we have no problem integrating sine 2 theta. So now we have negative cos pi plus cos 0, which is 1 plus 1. So finally we have our area as 2. Now we proceed with the second part, which is the length of a polar curve. The formula given for length of a polar curve is the integration of square root of r squared plus dr d theta square when the limit is from alpha to beta, provided that the function r equals to f theta has continuous first derivative for its limit, which is from alpha to beta, and the point p r theta traces the curve exactly once as theta runs from alpha to beta. What it basically means is that, for example, the cardioid r equals to 1 minus cos theta. After we sketch the graph, we can see that from the angle theta equals to 0 to 2 pi, the curve r equals to f theta has a continuous first derivative, and also the point r theta travels the curve once from 0 to 2 pi. Therefore, we can use the formula of the length and where the limit is from 0 to 2 pi. Now we'll find the length of the cardioid r equals to 1 minus cos theta. So we'll find dr d theta first, which is the differentiation of 1 minus cos theta. So we have dr d theta as sine theta. Now we find r squared plus dr d theta squared so that we can simplify it. We substitute these values into the equation, and we have 1 minus cos theta squared plus sine squared theta. We expand this, and we substitute sine squared theta with 1 minus cos squared theta, and we have 2 minus 2 cos theta. So our length will be the integration of square root of 2 minus 2 cos theta when the limit is from 0 to 2 pi. We know that sine squared theta equals to 1 minus cos 2 theta over 2. So 2 sine squared theta equals to 1 minus cos 2 theta. However, from this equation, if I bring out square root of 2, I'll have square root of 1 minus cos theta. So we need to change this into this form so that we can substitute the value over here into the equation. We can see that the value of theta over here is half of the value of the theta over here. So by dividing the value of theta here over 2, we will have half theta, And since the value of theta over here is 2 times the value of theta over here, we have 1 minus cos theta. So now we can substitute this value in the equation, and we further simplify it, and then we'll have negative 4 cos pi plus 4 cos 0, which is 4 plus 4, and finally we'll have the length of the polar curve, which is 8. So to conclude everything, in this video we discussed about the area and lengths in polar coordinates, and this too will be the formula that you will have to know for this chapter 11.5. So thank you for watching our video.